Okay, well, thank you, and thanks everybody for joining the web conference here. I want to make a clarification as to what the topic's about, because I was looking at what people expected in the sign-up, and most of the time it's aligned with what I'm going to be delivering, but sometimes it wasn't. This isn't going to be, architectural patterns, nor is it going to be like specific implementation advice and that sort of thing. What it is it's axioms or lessons learned in the field that can provide general rules of thumb to you while you're working as an architect, or for those who are aspiring to be software architects. So if you're okay with that, stay in the line. If that doesn't sound like what you were interested in, then feel free to jump off at any time. So my name is Richard Monson-Haefel, and I've written a couple books for O'Reilly. One book, the Enterprise Java Beans book, was originally authored by me and is now co-authored with Bill Burke. I also wrote the book on Java Message Service a while back, and I wrote a book for another publisher on J2E Web Services. So this book, upon which this presentation is based, is actually the fourth book I've written. I'm currently a senior experience architect at a company called Customer Solutions Group, working in multi-touch development with Microsoft Surface and iPhone and that sort of thing. But what I want to talk to you today has really no direct correlation to the kind of work that I'm doing right now or I've done in the past. I've worked as an architect for probably 12 years. I've been in the field for probably about 15. And it's just basically things that I've discovered along the way. Now, the impetus for all this was a show I do presentations for called the No Fluff Just Stuff Show, and the person who runs that asked me, he said, if I could do a presentation called 10 Things Every Architect Should Know. And armed with that title, I went forward and asked a bunch of other architects what they thought were things that an architect should know. And they gave me lots and lots of ideas. Basically, every one of them had a whole bunch of ideas. And it struck me that a lot of their ideas were different from mine, but actually really very interesting and things I hadn't thought of. And so from conversations with those architects came out the idea of creating a book in which architects from all over the world would contribute axioms or rules of thumb that they've learned. And then we'd look at them and choose the best ones. And that's basically how the book came about. So going to the next slide, you can see the cover of the book. It was just released this month, so it's brand new. It has 97 things, 97 axioms in it. The contributors, there's over 24 authors who have contributed. A lot of these names you'll probably recognize, some of them you may not. But almost all these people have a real solid reputation in terms of architecture and development. I shouldn't say almost all of them, they all do. And so the book contains all kinds of advice that I think you'll find interesting. What this presentation is not a rundown of the 97 things. There just simply isn't enough time to do that. But it's actually a run-through of 10 particular pieces of advice that I've been giving out for the past year and a half, doing a speaking tour and giving this presentation. So the presentation actually came first, and the book was a result of that. So moving forward, let's take a look at what the list of 10 are. Here's the list of 10 things I'm going to talk about today. These are not the only 10 things, nor are they the most important 10 things. They just happen to be the 10 things that I enjoy talking about during the presentation. There's actually probably hundreds of things you need to know, and that's why a book like 97 Things is so important. They're not in any particular order. It's pretty random, and so I'll just start at the beginning. The first thing I want to talk about is that people are the platform. And what I mean by this is that we develop applications all the time, and we're very concerned with the back end of things, connecting things together, making sure that interoperability is working, maybe with SOAP web services or with legacy systems or what have you, designing our enterprise beans or our swing applications or whatever it is, spring applications or whatever, but we forget about why we're creating these applications. And the people that we are here to serve are not the, are not the other developers or the back-end infrastructure people. It's the end users who are using the system. And keeping that concept first and foremost in your mind while you're doing architecture is critical to being successful. So I'd like to show a quote from different people who've contributed to this presentation in the book. This one is from Ben Geyer, who actually contributed to this presentation, but I'm not sure if he contributed to the book. And it says, applications are for making users as effective as possible. And that really is the bottom line. You can have the most elegant back-end architecture, the most elegant, rich internet application system, but if your users are not more effective, then it really isn't helping them. And so here's a little anecdote from my own past. Back in '94, I helped architect a client-server application where we moved an entire company from a green screen and a B-tree backend to rich rapid application development platform, Windows, and a relational backend. And we thought we were doing them a huge favor by giving them mice and icons and menu, drop-down menus and that sort of thing. And it turned out that these people were so effective with their green screen that they actually had immediate slowdown. And as a result, the revenue, the profits for the company dropped by about 20 or 30% during that year because everybody had to learn how to use Windows, and it turned out that it was not a more effective user interface. So that's just an anecdote from my past. What I'd like to talk about here in particular is, why the user interface is so important to the platform. If you look at this pyramid here, you'll see that at the top is the business. And the reason that we're doing our software development in many cases, unless you're doing open source, but for most commercial ventures is to, help the business, to make the business better. And the one thing that people will say in general is that a business is really only as good as its people. So the more effective your people are, the better your business is. If you, work with a bunch of idiots, you're probably going to have a fairly unproductive company. But if you work with a lot of really smart, savvy people, you're going to have a better company. So it goes without saying that the business really depends on its people. Well, the people actually depend on information systems. So in order for a business to be successful, the people have to be able to access the information they need in a timely fashion, in a way that's easy to do, and in such a way that they can actually use the information effectively to help the business grow. The one link in there between the people on which the business is based and the information systems, which is the knowledge that they use to make decisions, is the user interface. It's the linchpin in making that whole system successful. And that's why I like to say that the people are the platform rather than technology. Well, we have a limited amount of time, so I'm going to keep moving here. Here's another one. All solutions are obsolete. The idea here is that don't embrace or buy in too much into a single kind of technology, because usually a technology, fairly soon after it's been adopted by the mainstream, will become an old legacy technology. Perhaps not obsolete, but at any rate, certainly at the cutting edge. Sean Neville, who is a contributor to this slideshow but not the book, has a quote that says, hope that nothing you do will last. I don't know how many of you out there have been working for the same organization for an extended period of time, but if you have, then you probably have the misfortune of actually coming back and having to maintain systems you've already developed. And if you're like me, you've learned something along the way, and when you look back at your old work, you tend to cringe a little bit. That's one aspect of all solutions become obsolete. The other aspect of it, though, is that, let me go on to the next slide here, is that as we pick out solutions and we use them, we have to keep in mind that any solution you choose is not going to be the best solution in the future. So for instance, I may choose a solution right now, and in 5 years from now, it would probably be, not a very good choice. For instance, a lot of organizations were very into enterprise Java Beans and J2EE and those kind of things. And today, if they were faced with the same architecture, they might choose a very different type of technology, perhaps Spring or Hibernate or something to that effect. So just remembering that your decisions make sense today but won't make sense tomorrow is important to helping you, to guiding you in how you go about choosing the technologies you're going to use. Another aspect here is that data is forever, and I can't say this enough, that everything else is fairly ephemeral in your infrastructure. And I know that we say that there's a saying that, you know, once a system's deployed, it's always deployed. In other words, legacy systems persist. But the truth is that if you look at the infrastructure, the data, all the different kinds of programming languages and methodologies we use, they come and go fairly, you know, regularly. But the data that we use, the data that we depend on, is absolutely critical, and it is not ephemeral, and it's important that we take good are good custodians of that data. So here's my quote for this, and that is, technologies, methodologies, and business practices change, but data is forever. I'll give you an example of this. My father was last year sometime got a lawsuit against him. He's a builder for an apartment building he had built 30 years ago. And, you know, the claim was that, you know, this insurance company was coming after him because it had some difficulty and that he was ultimately responsible for it. And so he had kept all his information, all his data going back, you know, 40 years. And of course, this wasn't in the computers and files. But he went back and eventually found the file with the insurance papers that showed that he was still covered by his insurance policy that he took out when he built the apartment building. And, you know, ironically, the insurance company that had given him the coverage was the same insurance company that was attempting to sue him at that time. But the point is that the data that you use, the data that you have, is as important today as it is tomorrow and the next day and 40 years from now. So let's take a look at things that are ephemeral compared to data. If you look at it, there's all different aspects of what we do. One of the things is the kind of business philosophies we have. So for instance, when I was in school, just-in-time inventory was like the very centerpiece of all the business training that was going on. The Japanese had created this just-in-time inventory system, and they were kicking our butt in the U.S., and we needed to you know, adopt that system. And that came and went, and we still have just-in-time. And then during the dot-com boom, Business 2.0 became the big key phrase. Everybody had to do Business 2.0, down with the brick and mortar and up with the electronics store. And that proved to be valuable, but certainly not the end-all. Business agility, total quality management. Today, Six Sigma is really quite big. So all those things come and go. Also, the different methodologies we use. I learned waterfall when I was in college, and rational method was really quite big back in the 90s. And then today it's extreme programming, or maybe it's agile programming, and Scrum and that sort of thing. These too will come and go, as will the languages, Smalltalk, COBOL, Microsoft.NET, Ruby. These things are ephemeral. Today they're really important to us, but tomorrow it'll be something else. So for instance, when I started working in Java back in '96, Smalltalk was really quite strong, and within 2 years, Smalltalk had almost completely disappeared in terms of being implemented in the type of applications I was working on, and Java was being used. But the data the importance of the data never changed. And I'll tell you what else never really changed, was the importance of relational databases. Lots of different kinds of databases have come and gone. So I went through the period of time when we went from network databases to relational databases, and relational databases have really fared quite well ever since. We did see the rise of object-oriented databases. They kind of got a lot of press and a lot of excitement, but they turned out not to be all that reliable or performant. The XML databases made their debut and kind of came into vogue for a while, about 5-7 years ago. And today, now, it is these hierarchical databases, or these network databases that you find in the clouds. And people are asking, you know, is it the end of the relational database era? The answer is no. The relational database is going to be here forever. If you have to choose a kind of data store, and you have the option of choosing among, you know, some newfangled solution or relational databases, I suggest you choose relational databases, because they're going to be here for another 20 or 30 years. Flexibility breeds complexity. I think this is really important, and I'd like to go right to a quote by Luke Holman, who, by the way, has a few books of his own, one of which I really recommend is Beyond Software Architecture. It's quite excellent. But he says simplicity can create flexibility. The foundation of this is that in practice, simplicity and flexibility are kind of at opposite ends of the spectrum. So if you look at a one-celled organism like an amoeba or something to that effect, you'll see a very simple system. It's also rather rigid and constrained. In other words, it doesn't have a lot of bioflexibility outside of what its original intent is, which is, processing and nutrients and that sort of thing. At the other end of the spectrum, you see the human brain, which is really one of the most flexible organs, biological systems in existence. And matter of fact, it's so complex, we still don't know what's going on inside of people's heads, right? We can't figure it out. And so it's very flexible and very extensible, but at the same time, it's incredibly complex, right? So we can figure out the basic functioning of a single-cell organism, or how very simple organisms operate, but we still can't figure out how the brain really operates, and we have some clues. So the idea here is that simplicity and flexibility lie at opposite ends of the spectrum, and the more flexible you try to make a system, the more complicated it's going to tend to be. Now, the axiom here that's really important to take home is that if you try to build a system that's flexible, you'll probably get a system that's just complicated. But if you build a system that's simple, you might be able to build upon that to create something that's very flexible. So the example I always like to give is the use of pipes in Unix, which is the idea that you run a command line application, and the input to that command line application becomes the output to another command line application. It's a very simple idea, but it's actually really powerful, and it results in the ability to create extremely powerful system administration tools and that sort of thing. So that's an example of something that's very simple in concept that can be built upon to create very flexible systems. So flexibility breeds complexity. Don't shoot for something that's flexible from the very beginning. Shoot for something that's simple and build upon that. Nothing works as expected. I don't know about you, but every time I go to Best Buy and come back with some electronic device or other, it always, is thrilling, but there's also a level of disappointment because it doesn't exactly work the way I planned to. And that's one of the things one of the problems as architects we have is we get into the planning phase and we're looking at different technologies we want to use. We're looking at a vendor's application or maybe some other technology, open source and something, and we have expectations that that technology is going to serve us in a particular way. But in the end, it always will end up disappointing you. Sometimes it can surprise you, but most of the time it disappoints because it tends to be that our expectations are, outside the realm of possibility for that particular framework. Here's a quote from Nitin Borwanker, who is actually a contributor to the book. And he says, independent of what vendors say, the next version will not fix all your problems. And having worked for a vendor myself, I can tell you that the vendor will tell you almost anything to get you to buy their product. And sometimes, glossing over the truth is part of that. And so you have to be careful in dealing with vendors, and they start making promises to you about what their product's going to do. It's probably not going to do that. And whatever you imagine a technology that you have not actually used will do, it will do it differently than you imagine. A really good, interesting discussion of this is this idea of the Gartner hype cycle, which talks about technologies that come into vogue, get lots and lots of attention, are very exciting, and then suddenly, so they reach this peak of visibility where the expectations are so inflated that there's no way any technology could possibly achieve the goals that are expected of it. And then what happens is when it falls short of those inflated expectations, people's expectations of the technology drop severely, and it goes into this trough of disillusionment where nobody thinks it can do anything. And then slowly it balances out and reaches this plateau of productivity. So here's some examples I'd like to show you from Gartner's hype cycle for 2007. And at the very peak, if you look at the top, what is the item at the very top of the curve? Well, it's Web 2.0. And if any technology has been hyped to an extreme, it's Web 2.0 for sure. It might have been SOA, might have been there maybe a year or two earlier than that. And then before that, maybe it was XML, or a few years before that was Java, or what have you. Ajax, you'll see, is farther down the curve, and it's probably at a point now where it's starting to come back into the plateau of productivity. Tablet PCs were at one point a very exciting technology, but they just didn't meet the inflated expectations. So the point here is that as technologies become more and more popular and more exciting and gain more and more press, they reach a point where the expectations of them are far outside what they're actually able to do. And that's a very dangerous time to adopt technology. And so we want to be careful that, and remember that nothing really works as expected. Documentation is the universal source code. So I often hear people tell me that code is the universal documentation, or code is the documentation. And while I agree that well-written code is certainly helpful in determining how a system works, the truth is that documentation is the best documentation. That documentation may live in your code in terms of whether it's Java doc or API, but it has to be very thorough, and it has to be very clear as to what the intention of your API is, how it should be used, and what the expected behavior should be. In addition, you need other kinds of documentation. For instance, how would a person go about using APIs in order to achieve something? So just this very week, for instance, I've been attempting to use 2 different vendors' APIs to achieve certain kind of functionality on a multi-touch surface table, and neither one of them have done a very good job of documenting their APIs, and as a result, it's been really difficult to use their technologies, which are very powerful, in order to achieve a result, because I can't figure out which methods I'm supposed to be calling and in which order and that sort of thing. So documentation is extremely critical, but don't rely on just your source code as the documentation. You need lots of other kinds of documentation. So here's a quote from Don Bach, who, if you're in the Microsoft world, you'll recognize as kind of a pretty big name in that world. And he says, "A simple line of text is worth 1,000 pictures," which reminds me of kind of a funny anecdotal story. I went to work as a software architect at a really large financial institution. This was probably 10 years ago. And the first thing they did was hand me a 3-ring binder, one of those really big 3-ring binders. And in the 3-ring binder was, it was just full of papers. And I said, "Well, what is this?" And they said, "Well, this is our use cases." Now, they hadn't actually started doing development yet. I opened it up, and there was hundreds of pages of little diagrams showing use cases that they anticipated with their system, and the system really wasn't that big. It was at that moment that I knew that we were in trouble, and as a matter of fact, that project was basically a death march. It ended up being scrapped. But the point is that when I talk about documentation, I'm not talking about getting out there and using every kind of, use case and sequence diagrams and all that kind of stuff. That stuff's very helpful, but diagramming has limits. What I'm talking about is writing good English text that people can, if your language is English, that people can use to understand it. And here's the reason why. About around 1700 AD is about the time that the English that we use today, what we call the modern English, really developed. That's the time that Paradise Lost was written, and we kind of use that as the marker. And over that time, we've seen the English language used consistently throughout the last 300 years. And computer languages, and I'm sorry, I actually have a build on this slide, which is working right now, but computer languages really just started about 50 years ago. So in my opinion, saying that the code is the documentation is, inappropriate, considering the amount of time we've been working with the English language. So your best documentation is really written in English. It can be in the source code and elsewhere, but you need to do great documentation to have great projects. Software architects should also be coders. If there's one thing that you take home from this presentation today, this is perhaps the most important of all the points, and that is that software architects really need to get in on the ground floor and be coders along with their developers. And I'm not saying that you have to be coding 40 hours a week as an architect. In most cases, architects spend a lot of their times in meetings, and they just wouldn't have the bandwidth to do that. But what I am saying is that you have to be as familiar with your code base as at least your average developer is, and you have to know, but you have to know more than that. You have to know all the different systems. You have to know how they all come together. Excuse me, and how to apply the code in certain situations. So if we take a look at this quote from Barry Hawkins, who has quite a few axioms in the book, he says, "If you're unwilling to be hands-on, maybe you should be hands-off." And his point really is that if you don't understand the code and how it works, then it's possible that you're in the wrong place. One of the rules of thumb I like to give people is to tell them that if you're going to be an architect, set aside 1 hour a day or 10% of your time to go and sit down with other software developers in which you are working, and sit down with them at their desks and just watch them do their work and find out what their real pain points are. So if you work 40 hours or 50 hours a week, take 5 hours out of the week, maybe 1 hour during the day, and sit down with a different developer each day. At first, this is going to be a really uncomfortable situation for your software developers because they don't really like to have someone looking over the shoulders, and you'll notice that they'll actually be far more productive during that hour than they are in any other cases. But over time, you'll develop a comfort zone with them, and you'll actually be able to help them solve problems, and you'll really see where the issues are and where the real pain points are. And I think that's really critical to being a successful software architect. So it looks like in my moving through this, I actually skipped a couple of these, so I'm going to go back. Another axiom that's important is really you have to really know the business. Software architects live in a very strange place. You are responsible for understanding all the technology, but you also have to understand the business. And I'm not just talking about what you buy, what your company sells, and how it makes money. I'm talking about who the stakeholders are, what the personalities of the different managers are, what the business units need. You have to understand all this better than really anybody else. I think the only person who needs to understand this as well as the architect is the CTO himself. And this means that you have to not only understand all the technologies, network, programming languages, platforms, everything, you also have to understand all the business facets. And that is really the biggest challenge of being an architect, is being able to get your mind around all those things simultaneously. And the mark of a really good architect is someone who knows his business as well as he knows the technology. So taking a look at a quote here, again from Luke Holman, he says, the business stuff and the technology stuff are forever intertwined. If you're an architect, you learn to live in that white space in between. And that's really your job in a nutshell, is to connect the business objectives with the technology capabilities and facilities that you have to make your business more successful. The other thing is to maintain the vision, and this is another very critical aspect of software architects, and that is it's your job not only to understand the business and the technology, but to actually have a vision for how your organization is going to move forward in terms of IT, or how your product's going to move forward. And there's no other person that's going to have that total vision as you will, because your people on the business end are going to understand the business really well, but not really the technology. And the same is true for most of your IT people. But you have to be as familiar with the business as you are the technology. And so you're the only person who's really able to create a vision for the product other than the CTO. And so really the software architect is really their little CTOs, and to be perfectly frank, in terms of what they're responsible for doing. Now, they're not going to go out there necessarily and acquire and purchase equipment and that sort of thing, which is more of a CTO's job, but they have to have that same breadth of knowledge, and they're the only ones that can maintain the vision of the company and its technical direction. So, moving back down to the last point in this presentation before I take questions, and usually there's a lot of questions. There's no substitute for experience. The truth is that your best software developer is not always going to be your best architect, or is not going to always make for a good architect. Sometimes really great software developers are just really great software developers. They're not really meant to become architects. And I think knowing your limitations as a software developer and what you're willing to take on is important. A lot of people get concerned about the pay scale and where they're going to be able to go with that. And the truth is, if you are a really skilled software developer, you can maintain your pay level at the same level as architects and managers. You just need to seek out opportunities that will reward you for those skills. But when you go in to start a new project, don't pick the smartest guy on a team to be your architect, for instance, if you're a project manager or something like that. You really want someone who's been there and done it before, someone who's done software architecture in the past, has a track record that can point to. And they don't necessarily have to be, huge successes either. I mean, we learn as much from our mistakes as we do from our successes. So this kind of begs the question, well, if all you're ever going to use is experienced architects, how does anyone get experience being an architect? And the answer to that is what I like to call the architecture apprenticeship. And that's the idea that people who are aspiring to be architects should really look for architects that they respect and people that they feel really understand the role of the architect and what they're doing, and apprentice under them. Be their top developer, but really make an effort to learn the business and understand how they make decisions. And that's something you should do for a few years before you actually take on the job of an architect. And, while that doesn't sound very exciting to anybody, the truth is that you'll be much better prepared to serve your client and to have a fulfilling career as an architect if you've had some time to apprentice in that position. Unfortunately, most of us don't. What ends up happening is we're the best developer in the group. We jump up to being an architect just because of that fact, and then, we learn through experience, and our company tends to suffer because of it. So the last point I want to make is really there's no substitute for experience in architects. Please try to hire someone who has a lot of experience, but also provide opportunities for those who aspire to be architects to to work as an apprentice under your established architects and learn from them. And for this, Sean Neville, I have a quote here. He talks about, creating great enterprise software is a matter of intellect as much as wisdom and tenacity. And Sean Neville, if you don't know who he is the person who invented Flex for Adobe. He also was the first person to implement a commercial servlet engine, and he went on to help found Brightcove. So that's just 10 of these axioms, and these aren't actually word for word in the book. They're represented differently in the book. But the book has actually 97 of these points of advice. And whether you agree with everything I say or not, the fact that you're having a discussion and you're listening to someone voice an opinion who has experience in this area about a particular aspect of architecture really helps you formulate your own ideas and helps you sharpen your thinking of what it's like to be an architect and how to be a better architect. And with that, I'd like to turn it over to questions.
Hey, Richard. Catherine.
Hi.
You make it sound like architects have to think about a huge number of things. It's pretty amazing. They're close to being God, almost.
Yeah, well, they don't need to be omnipresent, but they really do need to understand both sides of the coin, and that's the business and the technology. And if they don't, they can't really be an effective architect.
What a lot of responsibility. We do have a couple questions coming in, and I'll ask them, and I encourage other people to send their questions too, because I think, Richard, you have to cut off right before the hour, right, and be on to your next presentation, or needing?
Yeah, I have a couple of minutes to play with, but yeah, at the end of the hour, I'll be out of time.
Okay. Someone just asked what architecture certifications are there, and he mentioned Sun Certified Architecture and TGAF certification.
So there are certifications out there. I actually don't put a lot of stock in these certifications.
TOGAF. Sorry.
Yeah.
Go on.
Okay. I don't put a lot of stock in them. To me, if someone has a certification from some kind of architecture, group or organization, that wouldn't really impress me at all. What would impress me is, what projects have they worked on in the past? How involved have they been in those projects? Who did they apprentice under? Those kind of things. So, certainly you can go out there and find these, exams that allow you to demonstrate at some level your understanding of architecture. But the truth is that the real knowing is when you're on the ground actually doing the work.
Right, right. And someone Ravi made a good point. He said that not everyone gets the opportunity to do that. And there was another question early on about some of the advice you were given. What about the software architect who has to work for other people and is in the position of following orders?
Yeah, so that's an interesting point, and I think this is what I tell people. Now, I'm a kind of an in-your-face consultant and employee. If I feel that a client is doing something wrong, or if they're going down the wrong path, I tend to tell them that. But the way I look at it is if you actually fulfill the role of software architect as I've described it here, and it's a very, very challenging thing to do. But if you can do that, then you really have the authority to make calls about technical architecture and enterprise architecture or whatever, and to challenge those people who are your bosses. And I know that's really hard to do. But let me ask you this. If you're a software architect, and I ask people this all the time in live presentations, how did you get that position? Did the guy ahead of you die? Or were you promoted because they thought you had the skills at hand to do that job? And I think most people will tell you that they were promoted because their skills were assessed and they were thought to be an architect. Well, bring that back to them and let them know that, hey, you hired me to do this job, and I'm telling you this is the situation. So it requires, that you have some guts and that you are willing to stand up to the people who are feeding you, so to speak, and to let them know when they're wrong.
Okay, good answer. We have another question from Bill who he says, describe the ideal relationship between the architect and the project manager in an organization, in a large organization.
Yeah, okay, so the architect, in one way, they're very conjoint. So the project manager, and actually, just to say, we have another book coming out in a couple months called 97 Things Every Software Project Manager Should Know. So we'll be able to answer those questions much better when that book comes out. But really, they're kind of conjoined in that, your software architect is really dependent on your project manager to ensure that the resources are available and that, that the schedule is followed so that they can meet goals. And the project manager is really dependent on your architect, to be kind of a reality check on where they are going, what they're doing, and whether they're going to obtain goals and they have the right number of resources. On the other hand, it's important that an architect try not to be a project manager and a project manager try not to be an architect, because they're busy enough as it is. And that can be really difficult to do. It's difficult not to say, I want these resources on this project and that sort of thing. If you frame your desires as requests more than they are as demands, you'll have a much better working relationship with your project manager. Fundamentally, the technical architect or the enterprise architect's job is to identify technical directions and evaluate solutions and make technical architectures, make designs. And the job of the project manager is really to find the resources and to allocate those resources in a way that will meet the time frame set by the business units.
Okay, excellent. And then Patricia's asking, do you have any advice on how to identify worthwhile new technologies while keeping things simple?
Well, so there's a lot of different ways to do it. I think the best is what I call the requirements and capabilities assessment model, which is something that I created when I was at the Burton Group. And basically what you do is you just come up with qualities that are important requirements, and you map those to capabilities. And then you see which products actually fulfill those capabilities, those requirements the best. And the ones that have the overall best fulfillment tend to be your better solutions. But that's a graphing solution, and I think what happens is we end up coming up with 2,345 touch points that a technology needs to address, and really you have to think on a much more broader scheme of things. For instance, really is performance really that important to your organization when you're doing batch processing, or is what does network connectivity mean? Do you have to have network connectivity? These are all the questions you have to ask. And what's interesting is in the book 97 Things, there's quite a few contributions that talk about really ferreting out the real requirements behind requests. And I think that's probably the most important aspect of being an architect.
Okay, 2,000 plus. Here's another question. It's from Jordan. And how complete and well-defined does the project's requirements documentation have to be solid enough to build on while still being maintainable? Sort of convoluted. Did you get that?
Not really.
Well, let's jump to another question, because maybe, Jordan, you could reword that and send it.
Oh, wait, I think I see the question here. Let me read it myself.
Okay. I probably didn't read it clearly. Oh, Jokin. I can't say that name. I'm sorry.
Yeah, even reading the question, I'm still not exactly sure what he's asking. But, documentation is never finished. We put it that way. If you look at anybody who's going to be using your system, and a lot of times that can be one of two audiences. If you're creating a product that's going to be software developers in your development community, if you're creating a technology that's going to be maintained, that's going to be your maintenance staff, people who are going to come after you and maintain the system after you're gone. You can't give them enough information on how your system works and all the different idiosyncrasies about it and that sort of thing. Documentation needs to be as high a priority as coding itself when it comes to creating a system.
Okay. Then the question about the book. Do the book and the wiki talk more about moving from the theory of the 97 things to the practice of the 97 things? You hinted a little at it here with a couple of the axioms.
Well, each one of the axioms that are presented in the wiki and in the book actually are very pragmatic kind of pieces of advice. We're pretty careful not to get anything that was too ambiguous, like be a good person or something like that. And, what we asked people to do was, if you're going to write an axiom and you have some rule of thumb, tell the person at the end of the axiom, because each one's about 400 or 500 words long, how they can actually go about making that happen. And the advice is general. It has to be, because you could be an embedded systems architect, or you could be a network cloud architect or whatever. And so we had to make the advice general. But what we try to do is bring it back to concrete ideas that people can that are actionable immediately.
Good. What I love about the book is just the 2-page essays inside. They're so easy to read, and it just seems like it would be the greatest book to carry around and just open it to an essay and learn something.
Well, it turns out if you have a rule of thumb you want to express, a lot of times less is more in terms of saying what expressing what you need to say.
Yes. Now here's another question. Do you think there are different kinds of architects, for instance, technical, enterprise, and application architects?
I do. For instance, I've always considered myself a technical architect and not an enterprise architect. An enterprise architect really has very different concerns from a technical architect. And although we both have responsibilities for understanding the business, the enterprise architect has a more holistic view of the systems across the entire enterprise, whereas the technical architect tends to focus on one set of solutions. That's where my comfort zone has always been in technical architecture. While I've met quite a few people who make it for excellent enterprise architects, and it's actually a joy having both people on a team because you get a much better perspective of what's going on. So when I say that an architect has to understand the business as well as the technology, an enterprise architect really has to understand the entire business. That's a much more challenging job, I believe. And a technical architect really needs to understand the business in terms of the aspects or the services of the businesses that their technology are addressing. So I think there is a big difference.
Okay, excellent. Well, I think that's all the questions that we have, unless anyone has one last question. But people have asked if you're going to share the slides afterwards, and I want to mention that we're recording this, and we'll make it available afterwards as a recording so you can watch it or you can share it with other people. That usually takes us about a day or two to, we have to convert it and post it. But Richard, are you planning to share your slides via SlideShare or anything like that?
Oh, sure. As a matter of fact, if you look at the bottom of the slides, they all say this is licensed under Creative Commons Attribution 3. So it's the open source version of content.
Right.
So you know, wherever O'Reilly wants to post them, I can make them available. Or if
I can post a copy of them on our SlideShare page if you wouldn't mind.
That would be great. Yep.
Okay.
I have no problem with that at all. I do see one question here that asks what other resources can we use in order to learn Martin. One I really want to highlight here is the one I just brought up on this frame on the bottom right, which is Beyond Software Architecture by Luke Holman. I really think that this book really does a good job of addressing a lot of the things that architects are responsible for, but they don't necessarily think about until they get into that position. Another one is a book that came out called, that O'Reilly just published, that I think it's called Beautiful Code, which I think has...
We also just released one called Beautiful Architecture as well.
Oh, maybe that's the one I'm thinking of. At any rate, it provides it provides much longer essays on you know, great architectures and what people did, and there's fewer authors on it. But it's a different take on this theme, but it's still you know, I think it's a good resource for people to use.
And will the audio version of the presentation be available? Yes, we'll have the slides, and we will have a recording of the entire thing, so you can play it back, and it's just like being here. So that'll be a movie file.
On YouTube, I think. Didn't you say that?
We post it on our webcast page and on YouTube, and as soon as we have it up, I send a link to everyone who has registered for the event, so you'll get that in email from me.
Okay, sounds good. I did want to say we have two other books that are going to be coming out, not authored by... I didn't author this book. I did what's called editing it, which all the authors get all the credit for the contents of the book. But we have two other book projects similar to this. One that's being run by Barbie Davis, and that's 97 Things Every Software Project Manager Should Know. And I think that one's going to be really useful, especially based on some of the questions we got here. And then we have another one that's in development. Will be called 97 Things Every Programmer Should Know. And that again is going to be everything from career advice to advice on approaches to programming problems and that sort of thing. So I'm excited about those projects also.
Okay, I'm trying not to make a sales pitch, but if people are interested, we do have a code that will give you 40% off your book purchase from O'Reilly, and you can buy one or more books and use it more than once. It's Forecast, and use that in the shopping cart when you check out, and it's good almost till the end of the month. So it's a great deal.
Excellent.
And I think that's it, Richard. I want to thank you so much. It was a fascinating presentation. I loved it, and I hope that the audience did as well. And everyone else, thank you so much for joining us. I hope you'll join us again for other webcasts in the future. And I think we'll just end the meeting now then. So.
Okay.
All right.
All right. Well, thanks everybody, and good luck with your own endeavors.
Good. Goodbye.